So we're continuing to graph aggregate expenditures. Again, we're using the workbook in drstephpowers.github.io/econ in Python. And you're just clicking here where it says aggregate expenditures to access the workbook. Once in, go to Google Colab, sign into your Google account and save yourself a copy so that you can run the code and amend the code within your own Google Drive. So we're here in the aggregate expenditure worksheet. We graphed aggregate expenditures and consumption and savings and found formulas for those in the previous videos. Well, in our previous videos, when we were looking at our savings function, we were graphing it according to national income. And when we looked at our consumption function, 5 plus 0.6y, again, we were graphing it against national income. But we might also want to look at it in terms of disposable income. So disposable income is your income after taxes. So here we have our national income from our original table, and here we have our net taxes. To find disposable income, we need to take income minus the net taxes. So let's find our disposable income, and then we can look at our consumption and savings related to disposable income as opposed to national income. The reason we do this is because disposable income is the income you choose what you do with, right? We are supposed to, we have to. It's against the law not to pay taxes. And so we want to look at how much you can spend from that discretionary or disposable income. So let's graph that, or at least calculate it. So let's go back down, and we're going to the section called disposable income. Now, because we want to find our disposable income first, I've just copied the line of code that's the national income. And the reason I've done that, rather than just continue on with what we have inputted, is when we were doing our linear regression, we had reformatted the national income data with that reshape command. Well, I don't want it to be shaped. I want it to simply be an array. And so I'm going to actually just put it in. I just copied in that line of code, says national income equals, and then the parentheses for the data. Because that linear regression command needs it formatted a certain way. But if we're going to do the calculation to find disposable income, y sub d, then we need it to not be that way. So we'll enter in our national income. We're going to enter in our net taxes. So this is just pulling this from the table. And then we're going to turn them both into arrays. So we need them formatted that way, np.array. And all we're doing is using the package, just go back up here. We're using import numpy as np. So if you didn't run that code earlier, you'll need to import numpy as np to make that work. All right, let's go back down. Okay, so we entered our national income, we entered our net taxes, we converted them both into arrays. We did not reshape them this time. And now we wanted to do a calculation. So find us disposable income. Well, disposable income is national income minus net taxes. So our NI minus T. So we'll just simply have it do the calculation for us. And to make sure that what it's doing looks right, we can simply have it call the information, provide it to us. And that's what you see here. So you can see if the national income is 0 and net taxes are 60, then disposable income, 0 minus 60, is a negative 60. And so here we have our disposable income. This would be like adding another column to the table at the top. Now let's plot this information. So we already have our savings and we already have our consumption entered from the previous videos. So we had entered in the savings function, for example, S equals, and entered in the data. And then we had converted it into an array. So if you haven't done that already, go back and enter in your savings and convert it to an array. Same thing with your consumption. If I go back to one of our previous sections here, enter in the consumption spending and turn it into an array. So since we did that in a previous video, we don't have to do that now. And so what we can do then is we can simply plot our savings and consumption relative to disposable income as opposed to national income. So notice here we're doing plt.plot. On the x-axis is disposable income, y sub d. On the vertical is the savings and the consumption. X label disposable income, Y label is going to be consumption and savings. And because we're going to plot multiple lines on a single graph, we can add a legend here. This legend is going to label them in the same order you told it to plot them. So since our first line of code told it to plot savings, we'll put savings first in the legend, and then we plotted consumption, so we'll put that second in the legend. The rest of the command here for the legend is simply to make the legend below the graph. That's what this negative 0.15 is. It's shifting it down, and it's kind of shifting it over towards the middle of the graph. This is over, this is down, and here I have two columns because I want to put savings and consumption side by side. That's what this number of columns equals 2 is. If you were plotting 3 graphs, you might want to make the number of columns equal 3, and so it would put the labels side by side, or if you have lots of them, you might want to consolidate to a smaller number of columns, in which case it'll stick the next labels below it. So let's run this. Here's our 2 graphs, consumption in orange, savings in blue. You can see our labels on our graph and our grid. And so we can see how when disposable income increases, we save more, we spend more. And again, we can find formulas for these curves here. And if we do that, we will need to reshape our disposable income, just like we did with national income. And then we do a linear regression. Here we can find the formula for savings. So we're going to fit y sub d, that's whatever's on the x-axis. And then on the vertical here is savings. Then we find the coefficient. We can also find the intercept if you want. So we could add a line here, model dot, oh, let me go back and run this one. I accidentally ran the next line, so then it would, it would give me the wrong thing. So intercept. So really what we just found, just to help you summarize it, is savings equals negative 50 plus 0.25 y sub d. That's what we just calculated here. And we could do the same thing for consumption. So we do a model, fit it. This time it's y sub d on the horizontal and c on the vertical. And we could find the coefficient. We could add in some code here and find the intercept if you want to find the full formula. Okay, and so what did we just find? Well, we found C equals 50 plus 0.75 y sub d. Okay, what does this tell us? Well, if we have no disposable income, we pull 50 bucks out of savings and we use it to spend. These have to be the same number, one negative, one positive, because this is after-tax income. You've pulled the money out. There's only 2 things you can do with it: spend it or save it. Okay, and then for every additional dollar of disposable income, 25 cents goes to savings, 75 cents goes to consumption. So our MPC, and this should be MPC sub D, is 0.75, and our MPS sub D, because it's of disposable income, is 0.25. When you get an extra dollar of disposable income, there's only 2 things you can do with it: spend it or save it. So that says that for every additional dollar, we spend 75 cents and we save 25 cents. Okay. This MPC sub D is important when we're looking at the spending multiplier. So later we'll look at calculating the spending multiplier. This helps us figure out if we're going to stimulate the economy with government spending, for example, how much of a ripple effect does it have? So if the government spends $1 million, how much does it grow the economy? Well, that really depends on how much of disposable income, so after-tax income, do households actually spend. That ripple effect of the government spending, creating jobs, giving people income, then they spend it, really depends on how much of that after-tax income people actually spend.